Hello and welcome to another exciting breakfast with Unity. Today we're going to be setting up a basic dual stick shooter control scheme thing, and this is going to be, I think, one of our easier episodes lately. Hopefully, I'm going to eat my words naturally. So what we're going to do is I've already created a scene. Dual stick shooter is just a empty scene. I just did this so that we didn't have to do that on camera, and there's a folder for it. So what we're going to do first is we're just going to set up a basic control scheme for this. So we're going to have the cube be our hero again, and this is going to be our little dude. And I'm just going to put the camera kind of above the character. So we're going to put it at 10y 0 here. Actually, let's give it a little bit of an angle. So let's do 10y 5z or negative 5z. And then rotate this down so that we can see our cube. There we go. And let's go ahead and create a, what is it called? What are we creating? We're creating a light, directional light. And so if we look at our game, we can see our cube. There it is. And we've got a little bit of depth. You can see the side of the cube there. So let's start with the basic movement. So I was kind of shocked. I was looking in here and I looked for move. And we don't actually have a basic move in any direction thing. We have a move up and down that we did once, but we didn't actually do one of our most standard movement things. So we're just going to call this, I'm just going to call it move in, move on axis input is what I'm going to call it. And that's not how you create a new one. You're going to create C# script, move on axis input. And I'm just going to get rid of this better snap tool. And what we're going to do here is public float speed. We've done this one quite a few times. I don't think we've called it exactly these words before, but we've done this concept for a while. So public float speed, and we're going to do public string horizontal axis equals horizontal, and we're going to do the same thing for the vertical axis. Vertical. These are the built-in defaults for horizontal and vertical, so this will give us something that'll work right at the start, and we want this to say equals there. So this will mean that we can slap this on something and it should theoretically work. We don't need start. All we need is update, and this is effectively a one-liner. All we're going to do is transform.position plus equals, so we're going to add to our position vector3.right times input.get axis horizontal, and then we are going to do plus, and this is going to be the same thing, except we're going to use vector3.up, and we don't want to actually say horizontal there. We actually wanted to use horizontal axis. That way we can change it if we need to, which we will, because we're going to, well, actually, I guess we're not going to change it on this one, but we might need to change it at some point for some reason. So we do all that, and then we can choose to, so we can then multiply both of these by time.delta time, or we can normalize it first. Which should we do? We don't do normalized movement much. Let's just do it. So dot normalized times time.delta time. So the difference between doing normalized and not is if you normalize it, it means that you can only move 1 unit per second in any direction. If you don't normalize it, you can actually move faster at the corners. Sometimes that feels more right if you're going for an old school style, but I figured we'd normalize it this time. So this will make it so that if you move it in a corner, you'll still be moving the same speed as if you were moving up or down. And we have an unexpected symbol. That's because, hold on. Oh, we didn't put a semicolon. That'll help. Save. So what this means is we're taking the unit vector right and multiplying it by our input, our horizontal axis, which is a number between -1 and 1. So this will either be pointing all the way left or all the way right based on the stick. And this will be either pointing all the way down or all the way up. And actually it can be in between as well. And all this will work. So let's see if that compiles. It compiles, yay. I don't know why it selected target manager there, but that's weird. So we're just going to put this on our cube. and this actually is not exactly what we want because we're doing vector 3 dot up. You'll see what happens. So we're gonna just put this on the cube and see what happens. And so when I move left and right, so when I'm moving up, I'm actually moving up. I actually don't want that. So that's not intended. So let's make this so that it says vector 3 dot forward. Save. So, all right, there we go. It's moving along the axes that we want. Let's make that speed a lot faster. 1.0 is just pathetically slow. Let's make this 6 at minimum. Let's see how 6 looks. That's still mega slow. Oh, we didn't actually multiply our speed in. So times speed times time dot delta time. That will help. Now that 6 will actually look like 6 times faster as opposed to exactly the same speed. Whoops. There we go. The smoothness is actually due to the way the inputs are set up, so we could actually kind of make that a little tighter if we wanted to. Input, we're currently using, this is on the WASD right now because horizontal and vertical, we set that up in previous series. So these have gravity and sensitivity. I'm going to make it more direct. So this will make it so that this will be more of a direct control. So if we hit play now when I stop, it actually stops. There we go. Looking good. All right, so we got the movement. So let's do the shooting now. So we're going to create a C# script. We're going to call this shoot on axis input. All right. So we're going to have public float. Actually, let's just do public string. We're going to just grab these, copy and paste. And then we're going to need what we're going to shoot. So public game object bullet. And how fast are we going to shoot? We're going to do public float shoot delay equals 0.1f. And so what we're going to do is private bool can shoot equals true if can shoot and input.get button. We're gonna have this auto fire, actually not get button. So we're gonna figure out our vector first. So I'm going to create a vector 3 shoot direction equals and it's going to be very similar to what we've got here. Just going to grab the normalized. Actually, we don't even care about normalizing in this case. It doesn't matter. So I'm just going to grab all that. We're going to paste it in here. We don't need these two ending brackets anymore. So we're just doing vector 3 right based on the input axis and vector 3 forward based on the get axis here. So yeah, that'll give us our shoot direction. And so if can shoot and shoot direction dot magnitude, and actually do square magnitude because we're just checking to see if it's greater than 0 is greater than 0.0f. So if we're pointing in a direction, start shooting is what this says. So the shooting is going to be as simple as we're going to rotate the player so that it's facing what we're going to be shooting. So we're going to do transform.rotation equals quaternion.look rotation, and we're going to give it our shoot direction, and we can also give it an upwards. The upwards in this case is going to be Y, but I'm going to explicitly put it in case you need to modify this code later. We're just going to do vector 3.up. So that changes our player's rotation, and then we're going to do instantiate bullet at transform.position, and the rotation will be transform.rotation. Save. And we already have something we can use for bullet A. Oh, we have one more thing. So can shoot. So we need to say can shoot equals false, and then what we do is invoke reset shoot. Let's call it reset shot, and shoot delay. And then we just really quickly, I'll just change the start into that. Who cares? So reset shot, and all this will do is set can shoot to equals true. So so we're gonna put this on our cube, and right now, if we hit play, it should give us a bunch of null reference exceptions if we try to move. But you can see that it's actually rotating the cube now. And now all of a sudden I'm regretting that decision to change the inputs to be so harsh. I'm going to put it back to what it was at. And 3 and 3. So now it'll actually have some smoothness to the turning and stuff. So cool, that works. So now we're getting a null reference exception, so we need a bullet. So I'm just going to create a sphere real quick, 3D object sphere. We're not going to worry about making this collide or anything. We're just going to show that this works. I'm going to create a prefab for it. Do we have a red? Let's just create a real quick material. Red. We're going to call it red. We're going to put it on our sphere. And so our sphere should be red. There it is. So that's going to be our bullet. It's going to be our huge bullet. And we're going to need some AI for the sphere, because right now we're just going to create them and they don't actually do anything. So we already have a move forward script from another project from Grid Spawner a long time ago. So we're going to put that on our sphere. So we're just going to do add component, move forward. And we'll make it so that it moves at 10. And so now if we hit play, it still won't work because we didn't actually put the prefab in here. So we're going to go to the cube. We're going to add our bullet here. So sphere, put it in there, play. And if I'm just pressing WASD, it shoots in whatever direction we're moving. So now we can make it so that it's actually a dual stick shooter now very easily. All we have to do is we change the input axes. So again, a long time ago, we added these vertical 2 and horizontal 2. All I did was I just right-clicked and duplicated them, and then changed some of the settings. So horizontal 2 is set up for left, right, up, and down on the keyboard. So if all we have to do is just change the names here to horizontal 2 and vertical 2, and all of a sudden we can move with the left stick and we can fire with the right. So we can kind of move the opposite direction or the same direction or whatever. I don't understand why the rotation seems so slow, so choppy. That's weird. That just looks really choppy for some reason. Is it because I have different controls? What are these settings for? Vertical 2 and horizontal 2, 3 and 3. Okay, whatever. I say snap. Maybe we shouldn't have snap. I don't know. Okay, well, I'm not going to worry about it. I'm going to call this an episode. And yeah, I'd say that went pretty smooth. So, thank you very much for joining us. What was I going to say? So, if you have any questions, please email me, pushypixels@pushypixels.com. You can also tweet me at Drakfire, that's DRAKFYRE. Please donate to patreon.com/cookingwithunity. Really appreciate it. We need your support. Check how much has been donated. You can see it's not a lot. Like I really appreciate what's there. Like super appreciative for the people who have chosen to subscribe. But yeah, we need more support. And thank you very much. You guys have a great one, and I'll catch you tomorrow with another Breakfast with Unity and with a 2D Thursday or whatever we're doing that night. Have a good one.